Hey guys, we are Group 3 and today we will be teaching you about frequency and sound. The vibrations that travel through the air or another medium and can be heard is known as sound. In simple terms, frequency is the number of occurrences of a repeating event. It is the number of wave cycles completed in a certain amount of time and depends on the properties of the source of the sound. It is measured in hertz, which is the number of cycles per second. Hertz was named after Heinrich Hertz, a German physicist who spent his career studying waves and their properties.
There are multiple aspects of waves that affect frequency. To better understand these terms, let's draw a diagram to demonstrate how frequency is displayed on a waveform. This is a waveform of a simple tone. A simple tone has just one frequency, represented by the singular curve here. The area from here to here demonstrates the period, or duration of time it takes to complete one full cycle. From here to here, the distance of a wavelength is demonstrated. A wavelength is the distance between two successive wave crests or troughs. It can also be demonstrated by this symbol, a lambda. Additionally, the measure of displacement of a wave from its rest position here is the amplitude. Next, we can compare this simple waveform to one with a higher frequency. Once again, here is the waveform of a simple tone. However, in the first waveform, there are less crests and troughs given an equal amount of time for both waves. This signals to us that the second wave has a higher frequency, meaning the second wave can complete more cycles in a given amount of time.
One of the main distinctions between frequencies, as you saw in the drawings, is whether or not they are high frequency or low frequency. The low frequency sounds have longer wavelengths and therefore longer periods, and the sensation that you actually hear can be described as a low rumble, while high frequency sounds have shorter wavelengths and therefore shorter periods, and what you hear sounds more like a sizzle. In addition, low frequencies travel well through barriers, while high frequency sounds reflect. This is the principle behind why you can sometimes hear or feel the bass from someone else's car when you're stopped next to them in traffic.
Frequency and period have an inverse relationship. Therefore, the formula to find frequency using the period would be f equals 1 divided by the period. Let's work one out. If the period of the wave is 10 milliseconds, then the frequency will be equal to 100 hertz. Wavelength can be used to demonstrate the relationship between the speed of sound and frequency. You can determine a particular frequency by using the equation f equals the speed of sound divided by the wavelength.
Each object or container has a resonant frequency that it naturally vibrates at, producing a certain frequency. The lowest frequency produced by any object is known as the fundamental frequency, or first harmonic, which influences the other harmonics of the harmonic set.
There are both simple and complex tones. Simple tones move in simple periodic motion with one frequency. Complex tones consist of multiple frequencies. Voice speech is an example of a complex periodic sound. As humans, there is a range of frequencies that the average person can hear. In most healthy young adults, the range of hearing is 20 to 20,000 hertz. In relation to speech, the range of frequencies most important for perceiving speech is 100 to 5,000 hertz. Depending on who is speaking, the range of frequencies heard will be different. For example, a woman will likely produce higher frequencies in speech, while a man will likely produce lower frequencies in speech. A fun fact is that if humans were able to hear sounds at a frequency lower than 20 hertz, we'd be able to hear our muscles moving.